on this?
Y equals 0.
Y equals 0? Do you all get that? And the x-axis, an asymptote for an exponential function is horizontal. The asymptote for a logarithmic function is the y-axis, is vertical. That's all. That's really all I want you to know of 7.4 that we skipped was what a logarithmic graph looks like, and that exponential asymptote will be horizontal, logarithmic asymptote will be vertical. Okay, what is an asymptote?
The line where it don't cross. The line, line where the line don't cross.
Yeah. The line that you could say your graph doesn't cross. The line that does not, it is not touched, all right?
The curve.
You don't touch the asymptote.
This one has a recon.
All right. So properties of logarithms, they're similar to exponent rules and properties. So we've got the product property. And the product property says that the log base b of m times n, okay, product, these are being multiplied, is the same thing as log base b of m plus log base b of n. So multiplication can be split up into addition like this, the log of each, and adding them together. We'll give you the same thing as the log of these. Multiplied together. Huh? Can I use a number? Yeah, sure. Yeah. So like, so if you have the log
Oh, that makes sense.
base 5 of 3 times 6 would be the same thing as log base 5 of 3 plus log base 5 of 6. Like that.
So it'd be log 5 of 18?
Yes, yeah. And sometimes you're given a number here and you've got to split it up into some factors. We'll get to that though. All right, the other one is the quotient property. Why is this marker so black?
Because it doesn't even want to do
It doesn't. It doesn't. Oh, that's a good one.
Nah, on snap.
Why
better
is the
than that.
heat on? I can feel it. Okay,
Bro.
quotient property. Any guesses?
Dividing.
Division, and what do
Oh,
you think it?
subtraction.
Yeah, very good.
Oh.
So the product property takes multiplication and splits it up into addition. The quotient property says that you can take one that's being divided, log of m divided by n, and split it up into the log of m minus the log of n.
Wouldn't that get like, one side is 18 but the other side is 9?
Jack's notes.
On the like, one side where if you go up, that one side is 18 and one's 9.
Oh, well, it's not the log, you're thinking the log of 3 plus 6. That's different than this.
Okay.
The log of 3 will be some number, and the log of 6 will be some number. And then you add them together, and it's the same thing as the log of 18.
Okay.
And I can actually, I gotta like spin from side to side. Okay, last one is the power, is it power property? Yes, power property. Can I erase the top here? I'm gonna erase this one and do it up here. Okay, power property. Says that the log base b of, oh yeah, of m raised to the n power. I'll use a lowercase n. If you have some number raised to the n power, it's the same thing as taking this little n and putting it out front. So n times log base b of m. So if you think about all the exponent rules, when you're multiplying variables, you add the exponents. When you're dividing variables, you subtract the exponents. When you've got a power to a power, you multiply the exponents. So these are all kind of related to the exponent rules, okay? So if you have this to a power, then you end up multiplying your whole thing times that. Okay, one little example and then we'll be done. Can I erase? We're going to use this given information to evaluate some logs. So if I have log base 2 of 3/7. Okay. This first one's really easy. All right, I've been given log of 3 and I've been given log of 7. So if we can turn 3/7 into some version of 3 and 7, then we can figure out what this log is. Because I know this one, I know log of 3 and I know log of 7. Okay? So 3/7 is the same thing as 3 divided by 7, right? So how can I split up division based on our properties? Subtraction. I can turn this into log base 2 of 3, which I have a number for, minus log base 2 of 7, which I have a number for, and I can figure all this out without necessarily needing to use the log buttons or anything like that. So log of 3 is 1.585 minus log base 2 of 7 is 2.8.
So be a negative number?
Yes. And so that is negative 1.222.
Will you have to evaluate it in every single way? Quotient, exponent.
Oh, no. It just depends on what you're given. This was all I was asked to do. It's dividing, so tell me what that number actually is. Sometimes it's not written out as obvious like that, so you could have the log base 2 of 21, okay? Well, I'm only given log base 2 of 3 and log base 2 of 7. Can I turn 21 into 3s and 7s?
Yes.
Yes. How do we do that?
7 divided by 3.
Wait, not divided.
Most likely.
3 times 7.
Yeah, 3 times 7. So if I change 21 into 3 times 7, now we're getting to something that I can work with. I know, I think in science, don't you talk about your givens all the time? Like, what are you given? What do you know? Okay,
Yeah.
so we're going to use what we know to figure out what we don't know. Okay, so this is multiplying. What's our rule for multiplying? Adding, yeah. So we would change this to log base 2 of 3. I have something for that. Plus log base 2 of 7. And I know what log base 2 of 3 is. It is 1.585. And then this one is our 2.807. And now we can just add those together. 4.392. Good?
Wow.
Yeah, good. We'll stop there. Bell spot's right in a minute. But we'll do more of this on Monday, review on Tuesday, test on Wednesday. Little test. It's gonna only be over like 2 3.
My radio.
Wish I knew.
I'm not gonna survive the rest of